Introduction to physics. Physics is a branch of natural science mainly concerned with matter in relation to energy. The emergence of physics as a field of specialization is a time-long process. People classify physics into classical and modern physics. This is to differentiate the older period concepts of mechanics, thermodynamics, Maxwellian electrodynamics from quantum theory. The pre-modern physics is classified into three periods. The first period from earliest time up to 1550 AD. During this long period, there was some advance in the accumulation of the factors in physics as a result of observation of natural phenomena. The second period from 1550 up to 1800 AD, numerous basic advances of physics were made by scientists like Galileo, Newton, Boyle, etc. It was a period of establishment of experimental method. This period, or the second period. The third period, 1890 AD, is characterized by the development called classical physics, in contrast with quantity physics of the present century. Now, this is the second period of the emergence of physics. In general, physics examines the laws of nature with the help of mathematics and well-arranged experimental setup and accurate measuring instruments. The main objective of physics is to find out natural laws and apply them for the development of technology and human life. That is the main objectives of physics is to find out natural laws and apply them for the development of technology for human life and measurement. Here, physics is the study of measurable properties of things. Most things and phenomena in our surrounding are measurable. These properties, which can be expressed by a certain numerical value or number, are known as physical quantities. In measuring physical quantities, they should be compared with standard units, and they should have a mathematical relationship between them. The next one is the scientific method. The scientific method is a process of investigating problems to get a certain result or to check what is predicted about the problem. There is no single method that all scientists follow. However, the most common steps to any scientific investigations are indicated below. The first step for this process is observation. This observation is the beginning step in the process of scientific investigation. The second step is problem or basic question. This problem is created because of observation. And the third step is hypothesis or theory. This hypothesis is an imaginative thinking which will be later proved or disproved. Experiment. The first step one is experiment, that is used to check the hypothesis. And the fifth one is data analysis. The recorded data during experimenting are systematically correlated. Conclusion is the sixth step one, that is carefully deducing from the correlation made. Scientific notation. Scientific notation is a simple method of writing a very small or very large number as a product of power 10. It can be written in the form m times 10 to the power n, where m is the one non-zero number or digit. It remains to the left information of the decimal point, and n is a power with negative or positive. Rules in writing numbers in a scientific notation. 1. Move the decimal point until only one non-zero number remains. 2. Count the number of places you move the decimal point and use the number as the power of 10. The power n is negative. The power n is negative when the decimal point is moved to the right, and positive when this number moved to the left. If the number is positive, the decimal point moved to the left. And here another point is prefixes. Prefixes are names with appropriate symbols given to powers 4 of 10. The word prefix means something put in front of another. Therefore, prefixes are put in front of units. For instance, in the number, for example, 5.7 centimeter, per meter is the unit meter. The letter C is therefore a prefix which stands for 10 to the power of negative 2. Thus, 5.7 centimeter is equal to 5.7 times 10 to the power of negative 2 meter. The number 6.53 times 10 to the power of negative 6 can be also written as 6.53 micrometer, when micro is the Greek letter read as mu, which represents 10 to the power of negative 6. Then prefixes can be named as exa, penta, tera, giga, mega, kilo, hectare, deca, deci, centi, milli, micro, nano, pico, femto, atto, and etc. And there are symbols for this given prefixes, and also it can be written the form power of 10 that the symbol represents. For example, hexa is and the power of 10 form, that's 10 to the power of 18. 10 to the power of 18. Penta, 10 to the power of 15. Tera, 10 the power of 12, giga 10 the power of 9, kilo 10 the power of 3, mega 10 the power of 6, and atto 10 the power of 8, negative 18, femto 10 the power of negative 15, pico 10 the power of negative 12, nano 10 the power of negative 9, and micro 10 the power of negative 6, milli 10 the power of negative 3, centi 10 the power of negative 2, deci 10 the power of negative 1, that is, which is equals to 0.1.